Hello, my name is Beth Dixon, and this is the second video in a series on box plots. Thanks to Vicki Borlaug for allowing us to use her PowerPoints on this video, and I'm picking up just where I left off in the first video, talking about outliers. Outliers is not the name of a new reality TV show about people living on the outskirts of town, but that could be a way to remember what an outlier is. Sometimes a data set has a value that just doesn't seem to belong. These data values are called outliers. Looking at this data set, which does not seem to fit with the other data. This is our outlier. And of course, as a mathematician, someone come up with a formula to calculate exactly what constitutes an outlier. So we will use the following procedure to identify outliers. The first step will be to find what we call the inner quartile range. I equals Q3 minus Q1. The inner quartile range equals the third quartile minus the first quartile. It's the distance between the two quartiles. Subtract Q3 minus Q1. The data values will be considered outliers if they are greater than Q3 plus 1.5 times that distance, that inner quartile range, which we call I, or if they are less than Q1 minus 1.5 times that inner quartile range. Outliers will be plotted as stars, and the whiskers will end at the data value next to the outliers. A word of caution here. I do these videos in compliance to the way Mrs. Borlaug teaches and presents the material in her PowerPoints. It is not the only acceptable way to do certain things, such as the box plot and outliers. Please check with your teacher for specifics. Remember that the first step in doing this is to calculate the inner quartile range. Let's look at this visually. The inner quartile range will be Q3 minus Q1. Imagine where those values are on your box plot. The distance between the beginning and the end of your box. That's the range we are looking for. Then we want to find the distance from the end of the box to 1.5 times that distance here to here, and 1.5 times that distance. So we take Q1 minus 1.5 times that distance. That gives us this distance here. Then we want to go 1.5 distance added to the Q3. That gives us this distance here on the right. Data values will be considered outliers if they are more than Q3 plus 1.5 I or less than Q1 minus 1.5 I. Again, this will be easier to show in an example, so hang in there with me and I will go over just a few more of these things before we get to an example. Notice that there will be at least one outlier in the left whisker because there is data below this mark here. These marks can be called fences or borders or the margin or whatever you want to call it. Fences is a good word and a word that is used often in our text. And it's because it's below that dotted line or this fence that there will be at least one outlier. Notice how the box plot is going to be redrawn. The next value down becomes a star, and the next value up in our list becomes the end of our whisker, and a star is put down at the previous end. Let's look at that again. Here is our fence. The dotted lines are our borders or our fence. Anything outside of that is an outlier, so it gets a star, and the next lower data value becomes our new lowest value, and that's the next value to the outlier. So this is what the box plot would look like without showing outliers, and here it is showing the outlier. And again, we've reached that 6-7 minute mark, and the example will take some time. So I'm going to stop the video again here where we've just discussed what an outlier is and how it applies. Please watch the next segment where we will go over in detail the example of how to calculate an actual outlier in an example problem.